So here we will introduce the concept of power and efficiency. Power is defined as du by dt, where du represents the elementary work over dt a small time step. So if we go back to the definition of work, work was defined as the dot product of f dot displacement dr. This is why, in order to define the power, we can also use a second definition, which is f dot dr by dt. And dr over dt represents the velocity vector. So it's derivative of position with respect to time. So we can say that power can be computed as f dot product v. And the unit of power will be in watt, while or joule per second if you want. Okay. Now, concerning the efficiency, any machine is characterized by a certain efficiency, because you know that we have always certain losses. The losses can be mechanical. You can have heat losses, heat by friction losses, etc. So in order to determine the efficiency of a machine, we divide the power output, which is also called useful power. So this is the power that is needed, over the power input. So in order to take into consideration losses, power input will be equal to the output power plus losses. Okay. So in general, each machine is characterized by a certain efficiency, defining what is the ratio of useful over total power supplied. Now, in case the machine is the energy applied to the machine occurs during the same time interval at which it is removed from the machine, so delta T of energy used as output is equal to delta T input, then delta T can be simplified, because we know that power is energy out over delta T, and power input is the energy that we are supplying over delta T. So in case delta T is the same, then we can simplify delta T, and the efficiency can be defined as the ratio of energy output over energy input. Now we will apply some problems on power. So we have the motor M of the host operates with an efficiency of 85%. Determine the power that must be supplied to the motor to lift the 375 Newton crate C at the instant point P on the cable has an acceleration of 1.2 meter per second square and a velocity of 0.6 meters per second. So first, what do we have in this problem? We have a motor. This motor is drawing a cable inward, okay? And when you draw the cable inward, your crate will be lifted upward, okay? So first, they gave us all properties at P. So we know the velocity at P. Vp equals to 0.6 meters per second. And concerning acceleration, we also know that the acceleration at P, so the motor is driving the cable at a certain acceleration, equals to 1.2. And we want to determine what is the power that must be supplied to the motor. So we should determine the power input, okay? Now, by definition, we know that the P input is equal to P output over the efficiency. Okay, so here in this problem, the efficiency is determined to be 85%. So in order to calculate, so we know the efficiency, then to calculate P input, we need to find what is P output. So what is the useful power here? What is the purpose of the motor here? Why we are using the motor as in this problem?
To lift the box.
Very good, to lift the box. So how can we write the output power? It's equal to what?
بنعمل free body diagram تبع البوكس.
Okay. we can do for the box. ساعتها شو حيكون
that S
نعم.
sigma s times v.
S
Yes, but مين بيقول لي P output okay هي equal to أي force times أي velocity.
التنشن تبع الكيبل.
Very good. إذا باخد أي cable بدك تحدد. Look هيدا في عندك two cables. You have this cable, this one, and you have the cable attached that is attached to the box. فيكم تاخدوا الاثنين وحنشوف شو الفرق. إذا بدي آخد هيدا الكيبل هون that is drawing inside the motor, the tension تبعه T. شو حتكون الباور ساعتها if I use this tension؟
T times V.
أي V مظبوط VP مظبوط. Velocity at this point at point P. Okay. So if I want to define the power output at the motor level اللي هو useful power, okay, هيكون tension in the cable that is drawn into the motor times velocity at point P. طيب كان فيني أفكر بغير طريقة كمان. فيني أفكر إنه useful power هو that will lift the box. يعني هو tension in this cable حسميها هيدي T2 if you want. So if I take this cable I have a tension T2 in it. I have that the output, the power will be in this case T2 times which velocity?
اللي هي 2T.
The velocity of C. Okay, so it will be T2 times VC. وحنشوف إنه هي ذاتها لأنه if we will find the relation between VP and VC and we will find the relation between T and T2 هيبين إنه we will get the same result at the end. So let us say we want to work with T times VP because we know velocity at P. So all we need now to find is the tension in this cable here in the motor. Okay, so let us say that we want to determine the tension here in this cable. This tension is the same over the cable here. So if I want to relate T and T2, what should I do? I should take the free body diagram of which part?
على البولي.
Very good. على البولي. إذا بناخد the free body diagram على البولي, this is the pulley. I have the tension T2 that is trying to pull down. And because I did cut at two levels on this cable, I will have T1 here or T. And here we have T also. And since the pulley is massless, we can write that sum of forces on our pulley is equal to 0. So 2T minus T2 equals to 0. And then we can write that T is equal to T2 over 2. Okay, so if we want to calculate T, we should try to find what is T2. And to find T2, we should know the acceleration of C. This is why, in order to use the information given, وأنا على طول قلت لكم بس يكون في system of pulleys, على طول relate motion of blocks أو points. يعني هون you can relate the motion of P to the motion of the crate C. Okay. Because you know VP and AP, so from here you can deduce VC and AC. Okay, so let us now do the analysis for the chords, the system of chords. What is the relation between velocities and accelerations? So as usual, the first step is to put the coordinates. I have block C is moving, and this block is connected to the center of the pulley. So they are moving together. This is why to define their motion, I just need one coordinate for block C, which can be just until the center of this pulley because they move together. So this is my first coordinate. And concerning the reference, also I am free to take any reference, one fixed. I can take the ceiling. I can take this line passing by the center of this fixed pulley. So here they choose this line as datum or reference. Now,
دكتور
نعم.
اذا عملنا فري بادي دايجرام على البولي مش بدنا ناخد الاكسلريشن كمان؟ ليه خدناها زيرو؟
لأنه الماسلس بولي مظبوط بدك تاخد الاكسلريشن بس sum of forces على البولي is equal to the mass of the pulley times the acceleration of C لأنه البولي will see عندهم نفس الاكسلريشن بس because it's a massless pulley يعني when they don't give you any information you treat the pulleys as massless so MP is zero. Okay, because MP
okay.
is zero, this will give you that sum of forces on the pulley is zero.
Yes, thank you.
Welcome. Okay, so the first coordinate, as we said, is S of C in order to consider motion of crate C. The second coordinate will be the one for the motor because the motor is drawing the cable inside. And إذا بدكم here SP will not represent just this distance. It's representing what is going inside the motor. Okay. So this is how we represent it. This is the coordinate, but here actually it's taking into consideration the total length going inside the motor. So now the total length of our cord will be equal to, so we have SC constant here plus SC, so 2SC is another constant. We have here also a constant. So all constants can be lumped together plus what is going inside the motor, so plus SP. So the relation I can write for the cord is 2SC plus SP equals to a constant. And now, if I derive this relation with respect to time, I get that 2VC plus VP is equal to 0. And now if I derive again, I get 2AC plus AP equals to 0. So in case you want to use for power T2 times VC, you can get VC from this equation. VC is minus VP over 2. And concerning the acceleration, AP is minus AC over 2. And AC is given to be 1.2 meter per second square. So AP will be minus 0.6 meters per second square.
دكتور قصدك العكس إنه AC هي AP over 2.
Yes, exactly. So AC is AP over 2. Yes. Okay. So now we got the value of AC. Since we know now the acceleration of C, we can now take the free body diagram of the block to find the tension. Okay. So this is the next step. We will take the free body diagram of the block. The forces acting on the block are the weight WC and the tension T2. And now we can apply Newton law. Please pay attention. نحن اخدين الcoordinate downward. يعني AC is negative. نحن ال AC اللي طلعناها هي based on this coordinate. So when you say AC equal minus 0.6, this is relative to the coordinate that is downward. Okay. So then when you write your Newton law, انتبهوا إذا قررتوا تاخدوا بالنيوتن law الupward direction as positive بتصير AC plus 0.6. Do not confuse yourself. خليكن على نفس direction. So since I considered SC positive downward, now I will write the Newton law in downward direction. So sum of forces along Y equals to mass times AC. I have plus WC minus T2 equals to, since now I am working in the positive downward coordinate, and AC is minus 0.6, so it's minus M times 0.6. And again, pay attention. If you decide, if you say I want to put y upward positive, then your equation will be minus WC plus T2, but here you should pay attention to put not AC equal minus 0.6, but plus 0.6, okay? And once you solve this equation, the only unknown is T2, the weight is given because it is here. And concerning the acceleration, we calculated. So the only unknown is T2, we can get it. Once we get T2, now let us go back to the power. نحن قلنا the power can be calculated by two methods, or T times VP, or T2 times VC. And you can demonstrate this again because T was demonstrated to be equal to T2 over 2, while the relation between VP and VC is that VP, because we said that 2 VC plus VP equals to 0, so you can replace absolute, يعني an absolute value if you want. Here I'm talking about absolute values, okay? You can replace VP by the absolute value of VC times 2, so 2 VC, okay? And then what will happen, that 2 will be simplified, and this is why they are equal, because it's true that the tension T2 is higher, it's double, but VC is VP over 2, okay? Yani you can conclude here, this is the concept here of, if you want, energy conservation. So we have that the power is the same, but with a smaller, let's say this is the concept which will allow you with a smaller force to lift a much higher weight. Why? Because what you are doing through the system of your pulleys is that you are reducing, if you want, the velocity. And here, with a small tension applied, okay, with a smaller tension you can lift a higher weight. يعني كل ما زدنا النمبر of هول النمبر of إذا بدكم البوليز والنمبر of connections فينا نوصل to lift a very heavy weight with a very small force using the concept. لأنه هون مثلا قسمنا مثلا على 2, يعني we need, let's say, here you are accelerating the system, you have a certain acceleration, but let's say you just want to have the equilibrium condition مثلا. إذا بس بتكون الكريت تكون in equilibrium, then you can supply إذا هو 375 Newton, you just need to develop a force in this cable equal to 375 over 2. لأنه فيها السيستم of pulleys اللي عم يبرم الكيبل 2 over the pulley، يعني بصير عندنا 2T بدل 1T. Okay. So هيدا كتير بيستعملوه to lift heavy objects. بتشوفوا مثلا بالملحمة وقتها مثلا بدهم يعلوا animals, they will use this, okay, because with a smaller force you can lift high weights. Okay. Any question on this problem? Okay. Another problem. Just before, and don't forget at the end to divide by the efficiency. And once you get P out, to get P input, due to losses, you might have here mechanical losses, you might have friction losses at the motor level. So you should divide P output by the efficiency, which is 85%. So Pn is P out over 0.85. Okay. Now, the second part that we will introduce is the conservative forces and potential energy. So always, sometimes you should know what is the type of your forces to decide if you can apply conservation of mechanical energy or not. So first, what is a conservative force? A conservative force is defined as a force that for which the work is independent of the path of motion. So let's say if I move from one location to another, For a conservative force, if I move in a straight path or if I move with any type of curves, the work will be the same. While if I have a non-conservative force, the work done by the force will depend on the path of motion. How we demonstrate if a force is conservative or not? We should find its work. So for example, for the work of the weight, we developed last time, if you remember, that if we take y positive upward, the work of the weight is minus w delta y. Okay? And delta y is just y final, here y2 minus y1. This means what? This means that whatever is the path I am going through, at the end, the work of my weight will be the same. This is why we say that the weight is a conservative force, because its work is independent of the path of motion. It is just depending on the initial and final position. Who can give me another type of conservative forces? شو شفنا كمان force work of a certain force that is very common? The spring. شو كان ال work of spring, if you remember? What was the work done by a spring?
half kx squared.
Yes, very good. عنا half k delta s1 square, okay? أو delta x1 square minus half k delta x2 square. So also for the spring, the work will only be depending on the initial and final state. This is why we can say also that the spring force is a conservative force. Okay? Now, why we are defining conservative forces? Because for conservative forces, we can always define a certain potential function. Okay? Once we define the potential function, we can use potential energy plus kinetic energy of the system will be conserved. We will see how together. So first, to start with, we will start by the gravitational potential energy. Okay, the gravitational potential energy is defined as following. If you consider this is the reference line, the potential energy is positive when you are above the reference line, and it is negative when you are below. Okay, so this is the definition of the potential energy. Now, in case I am taking y-axis positive upward, so if my y-axis is positive up, then the expression of the gravitational potential will be V gravitational equals to plus W1. Okay, because in this way, when I am above the datum, the potential is positive, and when I am below the datum, the potential is negative. On the other hand, if I take y-axis positive downward, then in this case, the expression of my potential will be Vg equals to minus W1, because in this way, y will be positive below the datum, and I know that in this region, my gravitational Vg is negative. This is why, in this case, y and v are opposite in sign. This is why Vg will be given by minus W1. So always pay attention for this formula for what is the positive direction of y you are taking. If it's up, you select the positive sign. If it's down, you select the negative sign. Okay, and I want to tell you also a remark that how we know that a force is conservative. We have a mathematical property saying that if I can find a potential function any way that the derivative of this function will give me the force. So here, if you derive the potential, okay, if you derive the gravity with respect to y, you will get plus or minus w, okay? So let us take the convention. We have the following convention, that if لما تكون y is up, okay, is positive upward, how we define the work of the weight? The work of the weight is minus w delta y. That's good. So you can see here that when y is upward, the weight force w is equal to minus wj, okay? And in this case, when I derive the potential when y is upward, the potential is defined, v gravitational is defined as plus w times y. So if you derive now, in
Doctor?
case نعم, yes,
بدي اسالك ليش عملنا derive للvelocity with respect to y مش للtime؟
مش velocity, this is not velocity, this is potential, gravitational potential.
اوكي
اوكي يلا I will
Yes,
repeat. هيدا السيمبل بس تشوفوا V يعني potential energy, okay? And here VG, so V stands بالهبلر notation, V stands for potential, okay? And the notation G stands for gravitational. Okay, so now إذا بتلاحظوا here we will have in this case في property بتقول إنه إذا بقدر لاقي function, potential function in a way that the derivative of the function will give me force, okay, that is doing the work, then I can say that this force is conservative. يعني هون بهيدا البروبلم نحن شفنا إنه الwork of the weight هناخد الكيس y upward, okay, ونفس الdemonstration على y downward. For the case of y upward, what is the work of the weight? The work of the weight is minus w delta y, okay, minus w delta y. So if you want here كأنه الwork هو إذا بدي أكتبه هيك هو minus w y2 plus wy1. مظبوط؟ يعني كأنه فيها الفانكشن اللي هي wy بطريقة إنه الويت هو الفاريشن of هالفانكشن, هو الدلتا of this function. Okay? This is why we can say إنه in this case we can define a potential function that will give us the work of the weight. يعني عنا the work of the weight can be written as the variation V gravitational at state 1 minus V gravitational at state 2. And we were able to find a function in a way that the work can be defined as minus delta V, minus the variation of the function. Okay? كمان it can be taken in other way. يعني إذا بتعتبروا إذا بدكم فينا نعتبرها بغير طريقة كمان. إنه if I derive V with respect to Y بيطلع لي الفورس. يعني هون if I derive the gravity بيطلع لي minus الفورس. If you derive the gravitational potential with respect to Y, what do you get? The gravitational potential لما تكون Y positive upward is defined by Vg equals to minus W times Y. So if you derive V with respect to Y, you will get plus WY. So if you derive V with respect to Y, you get plus W اللي هي minus إذا بدكم الويت. يعني هي minus هي equal للفورس لأنه الكومبوننت هي minus الكومبوننت للفورس لأنه الويت component إذا بناخد كفيكتوريال كفيكتور عنده negative component هي minus WJ. Okay, so here إذا بدكم in other terms we can say that a force is conservative if I can't find a potential function any way that the work of the force is equal to minus delta V. أو كمان فيني أقول if I find a function any way that the derivative of this function will give me minus الفورس. هن أصلا equivalent هول الاثنين. Okay, يعني هون أصلا if you perform integration of this you will end up with this result. So if you integrate يعني إذا برجع بتكتبوها dVg equal to W dy. Okay, if you integrate both sides, you will end up with the relation that the work of the weight here Vg1 minus Vg2. Okay, so a force can be stated as conservative in case we can find a potential function anyway إنه the work of the weight تكون minus delta of this potential function. Okay, وساعتها the derivative of the potential function تعطيني minus الفورس. هلا حنرجع نعمل لها demonstration بالاlastic energy. Okay, this is also valid for elastic energy. So here we can say that for the weight it works, we can find a function اللي هي لما تكون y upward هي plus wy ولما تكون y downward هي minus wy. This function can give me the work done by the weight by just doing minus delta v. Okay, and then I can say that the weight is a conservative force. Now, the second particular conservative force هي spring, because the spring مثل ما شفنا إنه the work of the spring U of spring was defined as half k. يعني أنتم من ال definition للwork بس تعملوا له calculation دغري بتبين معكم ال potential function، لأنه شو الشرط تبعها إنه هي الفانكشن يلي بتعطيني minus delta v بتعطيني الwork. يعني هون بكل بساطة الجرافيتي هيدي الفانكشن حتكون half k delta s square. Okay, where delta s represents the stretching or compression of your spring. So here it's very clear that the potential function I can define here v elastic لأنه هيدي v1 وهيدي v2. هون عندي ال variation of this function. So I can say that the work of the spring can be written as minus delta v elastic اللي هي v1 minus v2, and this function is defined by half k s square, where s represents the stretching أو compression. This is why بس نكتب half k s square بتكون ال unstretched position على الزيرو. Okay, إذا ال unstretched position مش على الزيرو بنكتب مطرح s delta l. يعني we can express it function of s. Okay, يعني مثلا example إذا قالوا لنا هون إنه ال unstretched إنه مثلا هيدي ال unstretched position هيدي L0, and we have that S we are counting S, let's say from this position here. في هون مثلا let's say 1 meters to S. Okay, then when we want to calculate ال V elastic delta L هي total length of the spring L total minus L0. فبتطلع على هالفيجر what is L total. L total يعني أنا for any position S هيدي ال S شو بتكون L total؟ بتكون L0 plus 1 plus S. okay, ساعتها بحط هون I replace LT by L0 plus 1 plus S minus L0. ساعتها ال L0 بتروح وبتصير إنه الدلتا S هي الدلتا L هي 1 plus S. So just pay attention على طول هيدا الترم هو بس ال stretching أو ال compression. لما تكون ال unstretched position هي ال S equal 0 ساعتها I can replace delta L just by S. In case it's not بتطلع على الفيجر and I express delta L function of S اللي هون مثلا هي S plus 1. Okay, so this is my potential elastic energy. خلينا نعمل verification كمان إنه if we derive this elastic energy هيطلع لنا minus spring force. فإذا أنتم بتعملوا derivative of V elastic with respect to S هيطلع لكم.
فكرة الدلتا اي.
نعم.
فيك تعيد فكرة الدلتا اي؟
Yes, sure.
دلتا
Yes, I will. Yeah. وقت نكتب V elastic equals to half K S square هيدي ال S represent stretching okay the stretching or compression of the spring. بس هون ليش ما حطيناها دلتا ال دغري حطيناها S؟ لأنه نحن هون اخدين إنه ال unstretched position هي على الزيرو، يعني لما يكون السبرينج unstretched على ال زيرو بتكون الاس زيرو، لانه نحن اخذين هيدي الاس عم نعدها من هون. اذا نحن عم نعد الاس من الانستريتشد بوزيشن يعني وات ويل بي اذا انا بعمل ديسبيسمنت اس هيدا الاس بيكون هو الستريتشنج. اذا اس بوزيتيف بيكون الفاليو تبعه ستريتشنج، واذا اس نيجاتيف بيكون هو ريبريزنت الكومبريشن. اتفقنا؟ ناو اذا اس منا عم نعدها من الانستريتشد بوزيشن شو بيصير؟ بتبطل الاس ريبريزنت ستريتشنج او كومبريشن. يعني احنا اذا بدنا نكون اكيوريت هيدي دلتا ال، وبهيدا الكيس لانه اخذوا الانستريتشد بوزيشن على الاس زيرو صارت دلتا ال هون بهيدا الكيس دلتا ال ايكوال تو اس. اوكي، بس ان كيس مثلا ان كيس غيرت الريفرنس، يعني مثلا تنقول بدك تاخذ الريفرنس هون، اذا انا قلت لك this is s equal 0 اوكي، ساعتها لما بدك تجيب انت الدلتا ال بالبروبلم تبعك، دلتا ال represent what؟ هي total length of the spring. يعني اذا هيدي الفاليو انا بسميها s مثلا، اذا انا عم عد من هون بتصير ال L total دلتا ال definition هي L total minus L0. اوكي، طيب فانا بدي اطلع على الفيجر to find L total function of s. إذا بتطلع على هالفيجر، إذا بنقي مثلا الأوريجين من هون، شو هي total length of the spring؟ طلع بهالفيجر شو هي total length of the spring إذا أنت عم بتعد الأس من هون؟ What
مش
is
L
S؟
بلس S؟
لا S، بس S. بقول لك ليه؟ أنت عم بتعد الأس من هون، اتفقنا؟ يعني أنا إذا بقول لك الأوريجين of S من هون، يعني أنا الأس represent the distance from this point to the board. ساعتها إذا هيدا الكوردينيت S تبعي، يعني S represent what بهيدا السكيم؟ It represent the total length of the spring، صح؟
مظبوط.
أوكي، ساعتها أنت إذا أنت أخذ الريفرنس هون، شو بتصير دلتا L؟ بتصير التوتال length اللي هي S minus L0. أوكي؟ يعني أنت كل فيجر بدك تاخدها لحالها. يعني إذا أنت هيدي الريفرنس ساعتها التوتال هي اس وبدي اشيل منها ال0 فيطلع لي دلتا ال، ساعتها الفي الاستيك هون بدي احط مطرحها هاف كي دلتا ال سكوير اللي هي اس ماينس ال0. اذا اخذت الانستريتش بوزيشن هون ساعتها كل ديسبيسمنت عم تعمله من هون هو ريبريزنت وات؟ ساعتها هو الدلتا ال. ليش هو الدلتا ال؟ لانه كمان جربها هون، اذا بدك تكتب انت توتال ال بهيدا الكيس، اذا انت اخذ هيدي الانستريتشد بوزيشن شو بتصير توتال دلتا ال؟ بتصير L0 بلس S. مظبوط؟ يعني إذا أنا غيرت ريفرنس حطيت الريفرنس على الانستريتشد بوزيشن بتصير L total equals to L0 plus S. ساعتها when I want to compute الدلتا L بصير عندي L0 plus S minus L0 and L0 then will be simplified so that delta L is equal to S. اوكي؟ واعطيت انا example. فهمتها؟ بدك اعيد الاكزامبل القديم او مش الحال؟
لا مش الحال دكتور، ميرسي.
اوكي Now concerning the definition of potential energy, you can verify now if you derive elastic energy with respect to S position بيطلع لكم 2 times 1 over 2ks يعني بيطلع لكم k times S يلي هي minus the spring force minus F spring. اوكي ولاحظوا هون مظبوط لانه السبرينج فورس هي على البول حتكون لما يكون السبرينج ان تنشن حتكون الفورس لورا ولما يكون السبرينج ان كومبريشن حتصير الفورس لقدام. يعني what is the expression of the spring force acting on the ball? F spring هي minus KS لأنه لما S positive بتكون spring force on the ball towards the left ولما تصير S positive سوري لما تصير S negative يعني لما نكون بالcompression بتصير spring force to the right وساعتها minus بتقلب بتصير plus فإذا مظبوط يعني minus KS بتزبط على الcase of tension تعطيني negative force وبتزبط على الcase of compression تعطيني positive force. So I demonstrated here also إنه the spring force is conservative لأنه I can define a potential function in a way that the derivative of the potential function with respect to S will give me the spring force. Okay. In other terms فيني أقول كمان by integrating this relation إنه the work of the spring force is equal to minus delta V elastic يعني is equal to potential elastic potential at state 1 minus elastic potential at state 2. Okay? Now, let us see a small example on this. هون مثلا إذا باخد a ball attached to a spring بدي جرب لاقي I will demonstrate again إنه ال work can be written as V1 minus V2 وهون ليش I can do this here? Because what are the forces acting on my ball? I have the weight and I have the spring force and both are conservative. لما يكونوا كل ال forces doing work conservative ساعتها فيني جيب ال work of these forces by summation of potential energy at state 1 minus summation of potential energy at state 2 لأنه انتبهوا على طول الأوقات بيكون عندكم elastic و gravitational. اوكي يعني بدنا نحسب هيدي ال V1 في بقلبها الالاستيك والgravitational potential. So if you do it here هنعمل بطريقتين الورك هنعملها عادي وهنعملها بال V1 minus V2. إذا بتطلع بهالفيجر عندي الويت والسبرينج. شو هو الورك اوف ويت؟ هون كثير انتبهوا على الكونفنشن، الاس كيف اخذينا هون داونورد. إذا بتتذكروا قلنا لما ناخذ coordinate downward بيكون الورك plus W delta S. يعني the work of the weight is calculated as plus W delta S يلي هي WS2 minus WS1. Okay, this is the work of the weight. Now for the spring نحن بنعرف إنه the spring force on a particle that we developed together last time is given by half K S1 square. أكيد عم نحكي إذا ال unstretched position هي ال origin لل S. أوكي وإلا بيصير بدنا نحط half K delta L1 square minus half K S2 square. Okay. Let us compare result. هلا إذا بتعملوا summation لهول الاثنين بيطلع لكم إنه total work حيكون WS2 minus WS1 plus half K S1 square minus half K S2 square. هنرجع نعمل إنه نفس الريزلت بيطلع لنا إذا عملنا V1 minus V2. Let us verify. قلنا إنه ال V1 will be divided into gravitational potential V1 gravitational plus V1 elastic. Okay. For the gravitational potential قلنا إنه وقت يكون ال coordinate downward شو بيكون V gravitational؟ بيكون minus. ليش minus؟ لأنه نحن بنكون تحت الديتيوم لما تكون S positive. يعني minus mg times S. فإذا بدي أعمل ال V1 gravitational حتكون minus mgs1 وال elastic potential حيكون plus half k s1 square. نفس الشيء إذا بعمل V2. أوكي. إذا بدي أجيب V2 حيطلع minus mg s2 و plus half k s2 square. Now if you replace إذا بتعملوا V1 minus V2 شو بيطلع لكم؟ بيطلع لكم W S2 minus S1 اللي هي ذاتها اللي لقيناها للwork of weight اللي هي W delta S وبيطلع لكم هالماينس إذا بنفوتها لجوا بيطلع لنا plus half k S1 square و minus half k S2 square اللي هي الwork تبع السبرينج. يعني هيدا represent the work of the spring. فإذا it's true. We can see here that for the work we can calculate it if the force is conservative we can calculate it by different methods أو بنرجع على definition اللي هي integral f dot dr اللي جبنا منها الفورمولاز للسبرينج وللويت أو بنستعمل if it's a conservative force فينا نستعمل potential function تبعها and say that the work of this force is minus delta v. Okay. Any question on this part? Okay. So let us do some application problems on this. Just before doing application problems, I want to introduce the conservation of mechanical energy. نحن already we defined the work and energy. كيف كانت the work and energy? T1 plus sum of work of all external forces between state 1 and state 2 equals to T2. Okay, this was the principle of work and energy. Now we demonstrated together that if only conservative forces are doing work, هلا في يكون في غير forces مش conservative بس ما عندهم work. إذا ما عندهم work مش مشكلة. Okay. يعني إذا عندي force non-conservative but is not doing a work, so I can apply conservation of mechanical energy. شو بيصير؟ I can replace sum of work between state 1 and state 2 by V1 minus V2 اللي هلا عملنا لها demonstration. And now if I rearrange the terms يعني بخلي ال 1 from one side with 2 from the other side بيطلع لي that T1 plus V1 is equal to T2 plus V2 where T stands for the kinetic energy and V stands for the potential energy. Okay, and this is called the conservation of mechanical energy. And I repeat, please pay attention. في conditions to apply this relation. إنه the forces doing work should be conservative. وإلا I should use our work and energy. أو كمان بالمدرسة من يمكن تعلمته another form. حدا بيتذكرها؟ كنا نزيد ال work of non-conservative force. وين كنا نزيدهم؟ من هالمان. يعني فيكم نزيدوا plus sum of work of non-conservative forces. Okay. هيدي another way بس صراحة أنا بلاقي أهين ساعتها تعملوا work and energy. Okay. So in case you don't have all forces conservative or you apply work and energy or you say that summation of work of non-conservative force plus T1 plus V1 equals to T2 plus V2. Okay. Now, what will happen if we have a system of particles? If we have a system of particles, simply we can say that sum of kinetic energy of all particles at state 1 plus sum of potential energies at state 1 equals to summation of kinetic energies at state 2 plus potential energies at state 2. Okay? Let us do some examples to practice on this. To begin with, we consider the following structure that is used to test the response of an airplane during a clash. The plane is characterized by a mass of 8 megagrams and is hoisted back until theta equals to 60 degrees. And then the pullback cable AC is released when the plane is at rest. Determine the speed of the plane just before clashing into the ground, for which theta will be equal to 15 degrees. Also, what is the maximum tension developed in the supporting cable during the motion? هناخد figure شوي أوضح من هنا. هي القصة is that we are testing the clash of an airplane. So this is the setup. You have a cable. The length of the cable is 20 meters. Initially, your cable, your airplane was held by cable AC. Suddenly, we will cut this cable. So when you cut this cable, you will have oscillation of your plane. أو هون لأنه في الفلور, you will have a clash. Okay. So the initial angle is 60 degrees, and just at the ground level before clash, the angle is 15 degrees. Now, first they want to find the speed just before the clash. So in general, why we should think about doing work and energy? Here we can think about doing work and energy because we know the initial position, state 1. We completely know it. We know the velocity at state 1 is equal to 0. We know also the position. Okay, يعني we can calculate the potential energy. And we know for the final position that theta is equal to 15. So also we can calculate the potential energy. But the velocity is unknown. So the only unknown is the velocity. And knowing the initial and final position, it will be a good idea to use work and energy. We can use other chapters, but هتشوفوا أن work and energy will facilitate a lot your solution. Now, بين الwork and energy والconservation of energy, both can be done here. Okay? بس لما يكون قادرين تعملوا conservation of mechanical energy, it's easier in general. Okay? So, why we can apply conservation of mechanical energy? First, we will draw the free body diagram of the airplane. This is the airplane. You have the weight of the airplane. That, of course, will do a work here because you have change in elevation. Whenever you have change in vertical direction, يعني the weight is doing a work. While if you are moving in a horizontal plane, the work of the weight will be 0. Okay? Now, concerning the second force, heat tension. What you have here, you have a rotation. Your airplane is rotating about a fixed point. هذا point here where you are attaching the cable. Okay? So, since your motion is circular, and the tension is along the radius, which is the cable, then the tension will always be perpendicular to the tangent line, and it's perpendicular to the path. So what will be the work of your tension? What is the work of the tension force on the airplane here? How you calculate the work of a force? You remember it's F dot dr, displacement. In this case here, the tension is always perpendicular to displacement because it's along the radius of the circle, so it's perpendicular to the tangent line. then it's perpendicular to displacement. So if the force is always perpendicular to motion, what will be the work then?
0.
0. Okay, so the work of the tension, since F here, when F is perpendicular to the R at any instant, this means that it cannot produce any work. Okay, so we can say here that the work of the tension will be 0. And as we said in the previous slide, if I have forces doing work and that are conservative, يعني ال T لو ما كانت conservative T, I don't care for it لأنه it's not producing any work here. Okay, so in this case يعني sometimes مثلا عادة الفريكشن بتكون non-conservative اتفقنا؟ بس if you have for example rolling without slipping, and we will introduce it after, بيصير عندنا إنه الفريكشن ما عندها work. يعني لما يكون الفريكشن ما عندها work صار فينا نعمل conservation of mechanical energy لأنه هي مزبوط non-conservative force بس هون ما عم تعمل work. Okay, and here the same for tension. The tension is not doing any work here, so the only force doing work is the weight. And since the weight is a conservative force, so I can apply the conservation of mechanical energy in this problem. وإذا كمان بدكم فينا نعمل principle of work and energy, both are right. هنعملهم اثنيناتهم here and you will see that it's equivalent. So now second step is to determine the terms of my conservation. يعني عندي kinetic energy at initial state plus potential energy at initial state equal to the final kinetic plus potential energy. At state A, the airplane is released from rest. So velocity at A is 0. Let me check your chart. Joe, concerning chapter 14 مبدئيا إذا حيكون included مش كله أكيد يعني maybe the first part بس if you find that you need more practice I will talk with Dr. Rani, maybe we just do 12 and 13 for the midterm.
معقول كمان يجي
Yes,
بونس؟
doctor.
نعم
معقول يجي شيء بونس؟
هلا مبدئيا هو it's a bonus chapter يعني انا اذا بتاخذوا رايي احلى لكم يكون موجود لانه it's easier من 12 و 13 بس if you feel you need more time to study it we can just do on 12 13 بس هو is very simple يعني خلص no problem خلينا لكن على انا I talk with Dr. Rani بنعمل هيدا الفحص على 12 13 and it will be included for the final بيكون ساعتها الباقي 14 15 16 اصلا ال 12 وال 13 حتشوفوا انه you need them بكل باقي الماتيريال يعني you should well understand them يعني even if we say for the final 14 15 16 مجبورين تعرفوا 12 وال 13 لانه تتحلوا ال 14 بتعوزوا ال 12 13 etc. يعني حتشوفوا مثلا بهالكيس هيدا البروبلم حنرجع نعوز chapter 13 to continue. Okay, so all chapters will be are related together. Yes.
عرفت شيء عن الميد تيرمز من الجامعة؟
الميد تيرمز بعد ما بعثوا لكم السكادجول؟
نحن بعتوا لنا اياه بس ما بعرف اذا عم بيقولوا رح يكونوا بريزانسيال.
ما عرفت
هلا
هيك.
هلا دكتور عندي فكره
صراحة
جديده
كان على اساس اونلاين كان. ما بعرف اذا صدر شيء قرار جديد بس مبدئيا كان اونلاين. اوكي؟
يعني للبارسيال عنا 12 و 13.
لا البارسيال 12 و 13. انتم بأيد 5 ماي انتم الاكزام؟
يس 5.
يس.
اوكي خلص 12 13. هلا اليوم بنخلص ال 14 الكور ونحن افتر الميد تيرم بنعمل براكتس على ال 14.
اوكي.
Yeah. So let us continue now. So for the initial position at A, we have that the kinetic energy is 0 because it's starting from rest. Now concerning the potential energy, whenever you have a gravitational potential energy, you should select a reference line. Okay? You can take your reference line at the floor. You can take it at the ceiling. اثنينهم صح. Okay? So both will give you right result because the choice of the reference will not affect your result. Why? لأنه أنا شو بيهمني آخر شيء بالآخر دلتا واي. and دلتا واي ما بتتأثر بالريفرنس، وين ما كانت الريفرنس دلتا واي هي ذاتها. اوكي يعني هون for example what is delta y؟ if you do yb minus ya هي هيدي الديفرنس، هيدي delta y. okay but it is a negative value لأنه y of b is smaller than y of a. so wherever is your reference delta y is negative equal to yb minus y. okay now let us say انه حناخد الريفرنس هون مثلا هن اخذين الريفرنس هي الفلور. اوكي اذا بدنا ناخد الفلور as a reference ساعتها البوتنشال انرجي لانه عم ناخد ساعتها حناخد y upward بتكون البوتنشال انرجي plus mg times y. okay now at point A what is y of A؟ y of A can be calculated as the difference between this distance كلها سوا اللي هي 20 meters. ليش فيكم تقولوا 20؟ هلا هون لازم يوضحوها كمان لأنه هي الكيبل length total هي قد ال height of the car. okay so this is 20 meters. this is 20. we should subtract from it this part. okay هيدي ال length knowing that this angle is 60 degrees. So this angle here also will be 60, alternating angles. This is 60 degrees. So you can say that the length here is 20 cosine of 60. And then the distance YA will be 20 minus 20 cosine 60. إذا أخذتوا الريفرنس السيلينج بيصير البوتنشال minus mgy وبتصير الواي هيدي الديستنس this one اللي هي 20 cosine 60. بس اخر شيء حتشوفوا انه نفس الريزلت you know why طلعوا له. اذا انا اخذ الريفرنس الفلور حيكون هون عندي 20 minus 20 cosine 60 وعلى الفاينل بوزيشن بس تغير الانجل صار 15 حتصير البوتنشال W times 20 minus 20 cosine 15. فاذا بتلاحظوا ال 20 بتروح لأنه هون عندي W times 20 وهون عندي W times 20. This is why the choice of the reference will not affect your result. Okay? Now, concerning فإذا مثل ما قلنا at B إذا أخذين الفلور as reference بتكون mg times 20 minus 20 cosine 15. إذا أخذين الceiling as reference بتكون بس minus 20 cosine 15 times W. Now, the only unknown in this equation هي the velocity at point B. So just I can replace back and get the value of VB. Okay? Now, second question in this problem هي إنه to find what is the maximum tension developed in the cable during motion. هيدي الquestion بنعوز فيها chapter 13 تنجاوب عليها. Okay, why? Because we want to determine a force, the value of a force, so we will use Newton law. Okay? Now, since the value we are using, we want to find here tension, we should go back to the free body diagram and try to see how to calculate this tension. If we go back to the free body diagram, what are the forces acting on the airplane? قلنا الweight with tension. Okay? Now, because we have circular motion, أنا على طول قلت لكم بس يكون في circular motion فكروا دغري UTUN لأنه إذا بنعرف ال VB بنصير نقدر نجيب ال AN and we calculated already the velocity. okay? هلا نحن لأنه ما بنعرف وين ال maximum tension مفروض نعمل analysis على any angle theta وحنثبت مع بعض إنه أعلى tension حتكون على البي. So we will take now any position theta. For this position, we have the force T along UN. UN is towards the center of rotation, اللي هو this point. UT is tangent to the path perpendicular to UN. And we have the weight force. This is the weight force. The weight force is doing with UN إذا بتعملوا projection إذا بتعملوا elongation ل UN, this angle here between the weight and UN is equal to theta. Okay. Now, since T is along UN, so قلنا هيدي UN, هيدي UT, and this is normal tension force is along UN. Since the tension force is along UN, to get the expression of T, I will project on UN axis. Okay, so I will write that sum of forces along UN is equal to, first we have the tension T plus T, and we have the projection of the weight. The projection of the weight on UN is negative, in the negative direction, and it's minus W cosine theta. So minus W cosine theta equals to M AN. And what is AN? AN is V square over rho. Okay? The velocity at the point over the radius of curvature. The radius of curvature R here هو radius of the circle هو length of the cable, because I'm rotating around this point and I am attached to the point by the cable, so R is equal to 20 meters. Okay, now we found the expression of T. T here equal to mv square over R plus W cosine theta. طيب, this is T function of V and theta. Now, what is happening as I am going downward? As I am going downward, theta is decreasing. مظبوط? Let us verify إنه T is maximum for theta minimum. وقت theta تنقص, شو بيصير بcosine theta? When theta is decreasing, what will happen with cosine theta? It will increase. And what will happen with the velocity? Also it will increase. Why? لأنه from the conservation of mechanical energy, كل ما انزل, كل ما potential energy تتحول kinetic energy. So since as theta is decreasing, both terms here are increasing, V and cosine theta, then T will increase with lower theta. This means that the highest possible tension will be obtained for the lowest angle. And here the lowest angle is 15 degrees. So now all I have to do is to replace by at B, and already I calculated VB from the previous step. And theta corresponding is 15 degrees. So I replace in the equation of tension mVB square over R plus W cosine 15. I get the value of the tension. Okay? Any question on this problem? Okay, so let's do the last problem in this PDF. A smooth 2 kilogram collar C fits loosely on the vertical shaft. If the spring is unstretched when the collar is in position A, determine the speed at which the collar is moving when Y is equal to 1 meters. If in case A, it is released from rest at point A, and in case B, it is released at A with an upward velocity of 2 meters per second. So here also, the first step is to draw the free body diagram of forces to see if we can apply conservation of mechanical energy, or if we can apply just work and energy. So here we have the initial position is at A, the final position is at C. We know that at the initial position it's unstretched, so delta L at A is equal to 0. And since it's released from rest, so also the velocity for the first part, it's released from rest. Okay, so for the first part, VA is 0. Now, what are the forces acting on my collar at any position? I have the weight of my collar, W. I have the spring force, so I have F spring. What also? What are other? Do we have other forces here acting on the collar? Smooth collar, no friction. Now, يعني والرد is smooth also. So I also have a normal reaction. مين بيقول لي ليش لازم يكون في normal reaction بين الرد والcollar؟ Why I have a normal reaction here, do you know? Is your collar moving in in X direction? Or just in vertical direction?
vertical.
Vertical. طيب إذا بس it's moving in the vertical يعني شو sum of forces along Y لازم يكون along X sorry if motion
X
is
is zero.
yes sum of forces in X is zero. أنا إذا برسم الفري body diagram حطينا الويت is along Y حطينا السبرينج فورس لأنه it's a stretching case لأنه كان initially unstretched وعم بعمل له stretching spring force حتكون like this. طيب تقدر يكون عندي equilibrium along X كيف لازم تكون النورمال فورس من الرد على الكولر؟ مش spring force عندها positive X component يعني
to the
normal
left.
yes normal reaction should be to the left اوكي وهون لانه تخيلوا انتم بس السبرينج يشد الكولر حيضغط على هيدي البارت من الرود فهيدي البارت حتعمل عليه normal reaction to the left اوكي بس هيدي النورمال عندها work شيء
No, لأنه perpendicular.
very good ما عندها work لانه perpendicular to motion so u of n is 0 since n is perpendicular to motion. Okay. Now, second step is to say since my forces are conservative, the weight and the spring are conservative, so let us apply conservation of mechanical energy. أو كمان work and energy اثنينهم صح. فينا نعمل ال work of the weight هي minus W delta Y وفينا نعمل ال spring force هي half K delta S1 square minus half K delta S2 square وساعتها من ال work and energy بنجيب ال final velocity أو كمان لأنه all forces done on the collar are conservative then we can apply the principle of conservation of mechanical energy. So both work here. Okay? Now بالنسبة ل state 1 قلنا انه it's unstretched يعني potential energy V at A is 0 elastic. هلا بالنسبة للgravitational we need a reference فليش ما ناخد هاي الريفرنس الانيشال position ساعتها كمان V gravitational بيكون 0 at A. So also if we take the reference here at the initial position of the collar then the gravitational at A is 0. Now what will happen at C؟ خلينا نمحي لأنه عجقت شوي. At C we have both gravitational and elastic energy. First for the potential energy حيكون positive أو negative at C. If this is my datum line بما أنه I am below the datum يعني it's a negative potential. So VC is minus mg times 1. And concerning the elastic energy, so this is VC gravitational. To calculate VC elastic, it is equal to half K times delta L at point C square. What is delta L at point C? Delta L at C is defined by the total length of the spring, L at C, minus L0. So if you look at your figure, this is the unstretched length because at A it was unstretched. So I can say that L0 is equal to 0.75. Now concerning the total length of my spring, this is the total length of my spring. At this position, since this triangle is a right triangle, I can say that this length is radical of 1 square plus 0.75 square. And now I can subtract to get delta L at C. All I have to do is to replace the value here and subtract 0.75. Once I get delta L at C, I can apply the conservation of mechanical energy, and the only unknown will be the velocity at C. So let us see the details. So first we say, since all forces doing work are conservative, we can apply the conservation of mechanical energy. So TA plus VA is equal to TC plus VC. And as we said, initially it is starting for question A, it's starting from rest. So initial kinetic energy is 0. And since we considered the datum at A, so initial potential gravitational energy is also 0. And also, since it's unstretched, elastic is 0. يعني كله 0 at state 1, at state A. At the final state, I have half mvc square plus the potential elastic energy اللي هي half ks delta L at C square minus mg times y. So here, the only unknown will be Vc. I can calculate the value of Vc. And here, of course, I get Vc square, but why I will select the downward direction? Because I am moving down. Yani at point C, when I reach C, since I'm moving down, yani the velocity is oriented downward. So in case you have y positive downward, then if your velocity is positive. بينما if you choose y upward, then you should select the negative solution for Vc. Okay. Now the second question was, what if we give A an upward velocity of 2 meters per second? So instead of releasing it from rest, we give the collar an upward velocity of 2 meters per second. Everything will remain the same إلا TA بتبطل 0 بتصير 0.5 times m times VA square. طيب حدا في يقول لي لو قالوا لي it was released with a downward velocity of 2 meters per second, كان تغير شيء بالsolution؟ If we give the collar an upward velocity of 2 meters per second, or we give it a downward velocity of 2 meters per second, what will change?
بالماينس 2 بتزيد الفيلوسيتي.
نعم.
بس الفي تكون داونوردز بتزيد الفيلوسيتي لانه مع الويت.
لا. You know why? No. أول شيء خلينا نحللها physically وخلينا نحللها بالايكويشن. إذا بتاخذ الايكويشن أنت عندك الكاينتيك انرجي هي half m VA square. اتفقنا؟ يعني إذا A positive ولا negative minus 2 square ولا plus 2 square هي Z. هلا تنفهمها physically ليش ما بيتغير شيء. نحن عندنا conservation of energy صح؟ يعني في عندك losses شيء؟ في شيء losses؟ No. يعني
No.
أنت إذا أعطيتها upward velocity of 2 رح شو حتعمل؟ رح تطلع ترجع تنزل. بس ترجع توصل على A حتوصل بأي velocity على A؟ 2. يعني أنت إذا كبيتها لنزول أو لفوق بس ترجع تمرق ب A حتمرق ب velocity of 2 downward. يعني هي ذاتها. ليه؟ لأنه ما في losses. يعني أنت لو كان في friction كان معك حق. كانت downward بتوصل أسرع على C لأنه ما بتكون خسرت energy. بس أنت لأنه كل الفورسز conservative بس ترجع أنت حتعطيها upward velocity حتطلع ترجع تنزل. بس ترجع تمرق ب A حترجع توصل لنفس magnitude of velocity. ليه؟ لأنه energy is conserved. ما عندي losses. لو عندي friction مثلا كانت الفريكشن خسرتني energy كنت رجعت على A with a lower energy than T. ساعتها مزبوط بيصير downward case بيوصلني ل higher velocity at C. بس لأنه ما في non-conservative forces, all forces are conservative. بس ارجع على نفس البوزيشن حارجع بنفس الكاينتيك energy بس الفرق الوحيد I will change in sense. يعني velocity بدل ما تكون up حتكون down. Okay? This is why إذا كانت upward أو downward velocity in this case it doesn't matter for me لأنه مثل ما قلنا ال conservative forces ما الwork تبعهم independent of the path of motion. So I will obtain at the end the same kinetic energy at sea since I have no losses during my motion. Okay? Any question on this? طيب. Good luck for the exam. Happy Easter. And in case you have any questions, you can send to me by فيكم تبعتوا لي واتساب إذا بدكم ساعة اللي بدكم إذا عندكم question أو إذا بتفضلوا through Teams كمان. You can send me through Teams. So if you have any questions during studying, you can contact me. Okay?
دكتور في مارك حموش كتب بالشات كيف حيجي الفحص؟
Same style as exam اللي عملنا التست نفس الستايل يعني عندكم problems عندكم some concept questions اوكي وانا بعثت لكم كمان بعثنا لكم البريفيوس هيديك المره البريفيوس عن 12 13 كمان جربوا اعملوا كمان كان وقتها الميد تيرم بس عن 12 و 13 so try to do it اوكي
اوكي ثانك يو دكتور هاف ا نايس داي
اذا كان الفحص مش مبدئيا لحديت هلا اونلاين بس اذا كان الفحص بالكامبس then بيكون البروبلم ستايل يعني مثل ما عم نعمل انا وياكم ما بيكون ام سي كيو اوكي
اوكي
طيب يلا good luck باي باي